In the coastal waters of the Bahamas, a young lemon shark is on the run from a surprising predator, an adult shark of her own species. Half of her 17 siblings have already been eaten by the older generation, and it looks as though she's about to join them. But just as the predator closes in, she disappears into a thicket of underwater roots, safe in the refuge of the mangrove forest. Forests don't usually come to mind as a habitat for sharks, but various marine forests cover roughly 4.2 million square kilometers of the planet, providing food and shelter for 35% of the world's sharks. Deadly tiger sharks blend into seagrass meadows before pouncing on sea cows and sea turtles. White sharks hunt down seals in forests of kelp, towering 65 meters tall. And lemon sharks stalk forests of mangroves, the only trees on Earth that live in the ocean. All these ecosystems have their quirks, but mangroves may be the most unique of all. Harboring life between their roots and among their crowns, mangroves function as an essential bridge between land and sea. And to survive between these worlds, different mangrove species have evolved various adaptations that protect them and their resident sharks. Taking root in the unstable ground of muddy coastal regions is difficult, so mangrove seedlings germinate attached to their mother plant. Once they've grown large enough to survive on their own, these partially developed plants begin to ride the current. Most take root nearby, while some travel for several months before landing in a different part of the world. Once they've settled down, mangroves deploy tall, skinny stilt roots, crutch-like prop roots, or wavy buttress roots to support themselves in their unsteady terrain. These newly established mangroves have to contend with two additional problems. Seawater is high in dehydrating and potentially toxic salt, and the mud contains little to no oxygen. This combination would be lethal to most trees, but mangroves make the most of their marshy surroundings. Rather than being completely buried, mangrove roots are largely above the ground. This allows the microscopic pores on these roots to take in oxygen during low tide before closing to create a waterproof seal during high tide. Many mangroves also grow snorkel roots, which can take in oxygen through the same mechanism, or directly produce it via photosynthesis. To stop salt from entering their system, some mangrove species use incredibly fine filters in their roots. Others concentrate salt inside special cellular compartments, bark, or dying leaves that then drop off. Some species can even excrete the excess minerals through specially adapted salt glands. All these processes make mangroves more than a little salty, but that doesn't deter coastal life from living in their nooks and crannies. While birds nest among mangrove branches, fish lay eggs amidst their sprawling, complex root systems. Symbiotic sponges and sea squirts protect their host trees from hungry, wood-boring crustaceans. Crabs, snails, and shrimp eat algae, mussels, barnacles, and salty mangrove detritus. These animals in turn feed fish, which are devoured by shark pups roaming the roots. alongside occasional vegetarian meals of seagrass. But sharks aren't just the beneficiaries of marine forests. They're part of the glue that holds them together. Sharks limit the abundance of animals, which would otherwise overgraze these essential plants. Just as marine forests provide shelter to vulnerable baby predators, those predators grow up to protect their forest homes. Unfortunately, both sides of this delicate balance are under threat. Overfishing has decimated shark populations worldwide, and many marine forests are being polluted or cut down for coastal development. This destruction is especially dangerous because marine forests are one of the single most important ecosystems in mitigating climate change. Mangroves and seagrasses trap carbon between their roots, and fast-growing kelps export vast amounts of carbon to the deep ocean. Together, marine forests sequester around 310 million tons of carbon every year, capturing 3% of our annual global carbon emissions. So, like the sharks that inhabit them, humans need to fight tooth and nail to protect these essential ecosystems. We're going to ask the obvious question: why are sharks so awesome? Not convinced? Then maybe you need to watch this lesson instead.